Hello Year 12s. So in this video, we're going to be working through question 9 of the 2012 exam paper. This was the last question of the network section, which tells you that it's very, very tricky. It's also found in question 20 of your Drello textbook. So if you're doing your homework, you might get stuck on this question. Another reason why I wanted to record myself going through it. So let's give it a read. Let's see how we go with it. And then we'll also look at the examiner's report as well. So it says, John, Ken, and Lisa must work together to complete 8 activities, A through to H, in minimum time. The directed network below shows the activities, their completion times in days, and the order in which they must be completed. So here they are right here. Then it says, several activities need special skills. Each of these activities may be completed only by a specific person. Okay, so here are the conditions here. With these conditions, the minimum number of days required to complete these 8 activities is which of the following? Okay, so this is a bit tricky. So what are we going to do? Well, for this question right here, what I would want to do is before I consider the conditions that are applied to the network, I would just want to figure out the critical path. So before I consider the conditions, just figure out the critical path of this. I'm going to be using our alternative method to do this. So remember, you begin by putting a 0 at the start. That's an ugly 0. Let's try again, 0. And then you want to forward scan using green. So this will be 3. This will be 6. 6 plus 6 is 12. 3 plus 7 is 10. 3 plus 4 is 7. 7 plus 5 is 12. Remember, when you got a whole bunch of numbers meeting at a vertex, you want to consider the bigger numbers for when you're forward scanning. 7 plus 7 is 14. And then 12 plus 5 is going to be 17. That's the bigger number. So that means my earliest completion time is going to be 17. But remember, this is without applying the conditions, okay? That's important. Now I need to backward scan to figure out my critical path here. All right, so to do that, what I'm going to do is I'm going to go like this. I'm going to go 17 minus 5 is 12. 17 minus 7 is 10. 10 minus 5 is... Oh, sorry. Yeah, sorry, I'm going backwards. 12 minus 5. 12 minus 5, because you want to go backwards, right? This one's going forwards. 12 minus 5 is going to be what? 12 minus 5 is going to be 7. So that means I've got 10 and 7. 7 is the smaller number there. Remember, when you're backward scanning, you want to circle the smaller number. When you're forward scanning, you want to circle the bigger number. All right, we continue. So I'm going to go 7 minus 4 is 3. And then here, I'd go 12 minus 7 is going to be 5. 3 is the smaller number there. 3 minus 3 is 0. We continue over here. 12 minus 6 is 6. 6 minus 6 is 0. Now, once you've done that, you want to identify your critical path. And it looks like we're going to have multiple ones here. Remember, to figure out your critical path using this method, you want to see the same number going in and out. So for instance, 0, 0. So 0, 3, 3, 7, 7, 12, 12, 17, 17. But there's also another way you could have done this. We could have gone 0, 0, 6, 6, 12, 12, 17, 17. So we could have also gone that way. So that means our critical paths here would be A, C, F, and H. A, C, F, and H. And the other critical path could have been B, E, H. B, E, H. So what we have done here is we have identified the critical paths without considering the conditions that are applied. So this is going to be our first step here. All right, let's now move on to the next step, which is considering the conditions applied.